Interactions between different species can also determine the evolution rates for each different species. And these interactions we call symbiosis. Sim meaning together, bio meaning life. So we've got mutualism, commensalism, and parasitism. Mutualism is where both individuals benefit. And here I have a bee and a flower. And the bee is getting some pollen, where he's benefiting from a food source. The flower is benefiting because the pollen's getting all over the bee, and as the bee flies to another flower to get more pollen, some of that pollen will be released from this flower on the next flower, causing pollinization, therefore helping the flower's reproductive success. Both individuals benefiting. Commensalism is where one individual benefits and the other is not affected. Here, I have this cow-looking thing and a cowbird. And as the cow-looking thing goes around and pulls up vegetation, because he's a primary consumer, as he pulls up vegetation, he's exposing the soil below. And the soil below contains a lot of insects, therefore exposing a meal for this cowbird. So the cowbird is benefiting by being around this cow-looking thing to get the insects. The cow is not affected at all by the bird being around it. And then we have parasitism. Parasitism here, like parasites, we've got a flea, and this flea or tick, it's probably a tick, its head's in there. This tick is benefiting by this, whatever this organism is, by a meal. Well, this organism is negatively affected because this parasite is consuming resources from it. Mutualism, commensalism, parasitism. Predation is another type of interaction between two individuals that can drive each of their evolutions together, or coevolution. So we've got a predator here and a prey. And the predators within their population, some individuals are faster than others. Those individuals that are faster tend to get prey more often, therefore surviving better and reproducing more, and their offspring hopefully will get that characteristic that the parent had of being faster. Therefore, these and the genetics within this individual being passed on will be more persistent within that population. Well, also within the prey population, some individuals are faster. Those individuals that are faster tend to escape more, surviving more, reproducing more, and their offspring will have those beneficial characteristics as well. So as the predator gets faster, the prey gets faster. That can also be a scenario with camouflage. If there is a predator that can see a certain prey on an environment where it is, those individuals that are camouflaged better tend to survive better, leaving more offspring behind with those beneficial characteristics. And or looking at characteristics that could be considered defense mechanisms. Looking more at the defense adaptation causing coevolution, once again the selection pressure is the predator. As individuals with more defense than other individuals within their populations tend to survive more because the predator tends not to be able to consume the prey as well and or tends to stay away from it than other individuals. A couple examples here is the poison frog, marijuana being an example of a plant that develops a certain toxin that causes its consumer to try to stay away from, and or poisonous mushrooms is another one too. Because if you are a prey and you consume one of these two, a plant and a decomposer here, you're not going to be on your A game to try to get away from predators if they are around. Therefore, causing you not to consume them in the future. So another type of coevolution is competition. And we've got two types of competition here, intra-specific, interspecific. Intra meaning within, inter between, and specific meaning species. So intra-specific is like male-male competition. Or it could be male-to-female competition. Well, let's look at male-to-male competition. I've got an example down here. Those individuals that can compete more or can compete better tend to reproduce more than those that cannot. And the individuals that can compete better because of their genetics, because their genetics determines their physical attributes and or their behaviors. And if they can compete better, they can reproduce more, and reproducing more means more offspring, and those offsprings will have those beneficial characteristics that the parents had that enabled them to compete the best and reproduce more. And then interspecific, where you have between different species. Like here, a good example, I've got hyenas and lion competing for the different types of prey. So that competition will drive the selection for individuals that can compete better.